So today I will discuss about a particular structural engineering software. In previous explored with different types of softwares in the civil engineering field for different purpose. It could be a structural software for structural analysis and design. It could be used for estimation, for planning, or a simple drawing software for plotting. So I will discuss in details about a structural engineering software that is STAAD Pro. So let me share the screen. So from structural engineering perspective, the software that we may deal, one of the software is your STAAD Pro.v8i, Structural Analysis and Design Program, the full form of STAAD. Okay, so in STAAD, STAAD, STAAD stands for structural, S and T, A stands for analysis, and D stands for design, and Pro stands for program. V8I stands for version 2008, and I stands for interactive. Many other softwares besides your STAAD Pro for structural analysis to be carried out. So today I will discuss about the STAAD Pro software, and at the end of the class I will show you some hands-on videos on how to operate the software and how to do the analysis and design through it. So before that, we must is to be done for any structure. So we have to perform to get the response of a structure that is happening for the action of different types of loads that is occurring on the structure. So the analysis is done to calculate various stress distribution, the natural frequencies, the displacement that the structure may have, even the buckling loads that may carry. So to check all these parameters, the analysis is done for any structure. So if we have to deal with different methods of analysis, the different methods of analysis that are present could be your experimental method, it could be analytical method, or it could be numerical method. So these experimental methods are generally carried using a prototype model in laboratory where experiments are carried on. Okay, where a large scale model could be scaled down, and on that model the experiments will be done. There will be other methods of analysis like a for if we
सर आवाज अच्छे से नहीं आ रहा है सर
आवाज अच्छे से नहीं आ रहा. अच्छा, see if my voice is clear now.
Yes sir.
So okay, so in analytical method we deal with prepare a mathematical model and solve it to get the solution. Okay, in numerical method we actually deal with the critical analysis procedure. Okay, so one of the procedure is your finite element method. We will see what is finite element method. in upcoming slides. So before we begin, I would like to discuss about for your analysis of a structure. You know what is stress, what is strain, what is Poisson's ratio, bending moment, shear force. Okay, shear strain curves for different material. We know what you mean by linear or non-linear materials. Okay, what is isotropic, anisotropic, and orthotropic. So I hope all of you know these terms. You are aware with the you're conservant with these terms. You know what are the basics, and these are actually they are this have uh, actually by default it there will be certain or Young's modulus and for different materials. And in STAAD Pro, we have the values in there, but we can customize it for different. We can change the value of and we will obtain the bending moment and shear force from the analysis. Okay. So we are basically dealing with linear analysis. There are non-linear methods are also, and isotropic, anisotropic, and orthotropic. I hope all of you know. What is it? In isotropic, the materials in a material in all direction, in every direction, the property, the crystallographic property will be same throughout the material. Anisotropic is the opposite. The material property won't be same throughout the space of the structure. And in orthotropic, if there are three directions, three dimensions, then it would be same. It would be different for all three directions. This is the basic difference. Now let me discuss about finite element method. Okay, so it is one of the type of numerical method, one of the analysis method of analysis, and the STAAD Pro or most of this structural engineering design software, it is or it is your ETABS. So they actually deal with this method of analysis, that is finite element method. Okay, so the basics of this method is that it actually we actually consider a particular element, we divide and discretize this a particular a whole system into small fragments, and then we do the analysis for each part. And there are some examples of FEM, like your Euler's rule, Lagrange method, and Newton-Raphson method. These are higher order analysis. You can study further uh, in your higher studies. You can study. So we know different types of analysis methods. So basically, there are two methods. One is force method, another is displacement method. So within force method, you have I hope you have studied the strain method, consistent deformation. Then for your displacement method, you have Carney's method, slope deflection, okay, matrix stiffness, and FEM also. So this the basic concept of FEA means finite element analysis or FEM finite element method, both are same. So here what we do, we have a 3D model. We do we actually
हेलो सर,
we have two
आपको नहीं
ways
आ
we
रहा
can.
है।
It is network issue. Is okay. Only is the today जितना हो सुन लो as और अगर डाउट हुआ फॉलो द स्लाइड, अगर डाउट हुआ देन यू आंसर, कुछ भी नहीं आया तो because with network issue not much can be done. So as I was discussing the finite element method, what we do with it, we actually discretize the structural model. Means we actually divide the structural model into fragments. Okay, we divide it in terms of elements. and those elements, suppose in StatPro, okay, means beam means not our horizontal member beam. The beam element create column. We will create beams. Okay, there are plate type structures. Using that we can create slabs and different structures also. So the elements here uh, will be connected through nodes. Okay, the solid square yellow point that you are seeing are actually nodes. Okay, the joints in your joints of beam column joint, the two elements are connected through the nodes. Okay, and there will be support condition. So this is the basics of finite element analysis, where basic model, structural model is of a particular mathematical actual model, practical model into a FEM. For doing the FEM analysis, we transform it into different types of connected through nodes and through the node. Okay, matrix analysis we do for different for stiffness and flexibility analysis using these elements or open the of transforming into. Okay, in StatPro we do this discretization by using meshing. Okay, there is a term called meshing. We do our discretization by meshing, that is automatically done in StatPro, so we don't have to do it. We can change it where it is customizable. We can change the size of the mesh. Okay, the advantages and limitations of this StatPro. Okay, so we know that when we are doing manual calculation, it is very tedious process. Okay, it takes lots of time, and whenever the structure is big, we have to do the same calculation again and again for different shapes or structure. So it is very time consuming, and it is not also possible to do the 3D analysis, and we didn't it is difficult to get a overall view of the structure based on the analysis that we have done. Okay, but it is possible using the computer analysis, where we will get a mix of different structural analysis altogether. Okay, and using this finite element method we can also get the 3D analysis, and we even see the rendered view of and the von Mises curve, where how the structure is deforming, what is the nature, and of different this is the advantage of computer vision. The results are obtained. Okay, let me do one thing. Let me leave this and rejoin this Google Meet. Okay, I'm leaving and again I'm rejoining. Let's see if it works. see if it is working now. So using this computer, we can do the structural design of the building, and there are the quicker way of doing the analysis. Okay, we don't have to do the tedious manual way of calculating the complicated get the results very quickly. The a huge range of possibilities of doing dynamic analysis. Okay, the response spectrum or time history analysis can also be done. This is the advantage, and this deals with the actually deals with the seismic analysis. So we are actually we can do the seismic analysis, and we can simulate the earthquake and how is it the response on the structure due to the earthquake. We can actually do it. So, and we have also a broad range of materials that are available in STAAD Pro. One is your steel, then concrete, and okay. So here we will get the graphical view of the model that we are dealing. We are now there is a programmable editor part, STAAD editor part, and also we have a graphical interface. We can create our model and put all the loads and support condition and material properties. The graphical interface have a analysis and program that runs, and there is verification is always done using uh, the code we are dealing with. Okay, there is a broad range of codes that are available. Means besides your Indian standard code, your European code, British codes, Australian codes are also available. So in any final development method, there would be your processing and post processing. So in your pre-processing, there will be inputs where we will be giving field property, etc. And in post processing, you will get the output in terms of shear force, bending moment diagram, axial stress, your so we will also get isometric and perspective 3D rendered view of the structure. So these are all the advantages of STAAD Pro. That are available is your the graphical interface, the options there in terms of structural templates. There will be wizards available in the STAAD Pro model where you can have your still in terms of truss or frame structure, where you will just give the number of base and it will be created. The size you will give and it will be number of, and the height and stories will be created automatically. So there is a easier way and customizable way of creating a structure, a generalized structure, whether it is a frame structure. It's your SI unit metric. Uh, uh, implement your even linear, non-linear cables are also available. We have different facility for giving a so we have the feature of uh, shape of frame type structure. We can also provide cylindrical structures also. That is also, this provision is also there. So our with this it divides. So as discussed, the in the system, and we can also import the uh, DWG file. Okay, this is the drawing AutoCAD format where we can import DWG or in Excel file. So we can uh, import the model that we have drawn in STAAD Pro. We can import it in the STAAD Pro, and we can do the analysis there. So instead of rigorous model creation, we can do it in the in AutoCAD, and we can import it in the STAAD Pro very easily. Okay, next is your uh, post processing, where you will find the printable of all the outputs. Okay, get all the shapes of the structure and all the analysis that we have. Okay, and so that are useful for model generation could be done for creating a complex structure using your copy, repeat, or mirror. Okay, these are easy tools that are utilized for creating a structure effectively and very quickly. Okay, and you will also find library of number of structures that are displayed for the loading condition orientation. Okay, we will just see how the different loads could be created and generated. Okay, this part is discussed. Okay, now coming to analysis and design. So the analysis could be static, or so it could be a primary static analysis or P delta. The dynamic analysis could be done using the time history or response spectrum, eigenvalue or eigen. Okay, so we have basic design materials like have uh, number and also transmission. So with this, we can do the analysis in StatPro very effectively, and it has a broad range of analysis that it could be followed. The type of structure that we are dealing in StatPro, it could be your 2D truss or 3D truss. It could be a plain 2D or a single 1D beam. Also, you can create 3D space. You can create flow type structures. Okay, so you can see there is coordinate system is shown on your left corner. G, X, I think am I audible? Bonali, are you there? Bonali? Anyone just confirm me whether I'm audible or not?
Yes, audible.
So I've discussed about the trust 2D3 is not this have a decision about the structures that are found in STAAD. So you can find 2D truck, 3D truck, and find plane, 2D plane, 3D spaces. You can find so the different coordinate systems. There is a system, another is a coordinate system. So here on your left corner, you can see coordinate system. It is GX, GY, and GZ, where G stands for global, and X, Y, Z coordinate system. So in that we have the vertical upward horizontal plane is XZ. Okay, by default it is. And besides global coordinate system, means the whole structure should be having a global coordinate system as a feature as well as local coordinate system. Each element of the structure, means each beam part, each column part, um, will be having its own coordinate system that is called local coordinate system. Okay, local X, local Y, and local Z. That are line, truss, beam, surface, plate, shell, and solid. These are the basic structural elements that should be found. Okay. Boundary for the structure. Okay. The location could be fully restricted. It could be partially restricted with string. It could be inclined. It could be multilinear. We have also type of condition that on the condition we can create our support or generally we use the uh, fixed support for any practical purpose. So the basic steps that need to be carried out for padding analysis in STAAD Pro consists of etc. And the material properties means the Poisson ratio or Young's modulus uh, and Okay, breadth and width of the section. And length will be defined in terms of elements size. Okay, we have to give the support condition, means the boundary condition. Then we have to give the load and different load combination. We can give um, point load. We can give UDL. We can give varying load. Okay, we can give hydrostatic load, pressure also. Snow load is there, earthquake load is there, wind load pressure is there. A variety of different types of loads are present. There are some special commands also. The analysis, we do the diagnosis. We can see the a stat file. It will show like this. So you can see the logo of the stat pro in your recent files. It is shown. Okay. So here there will be license codes that are available. You see there are a huge library of codes that are available here, like Euro codes. Okay. Mm, uh, and uh, structural wizard to use a predefined structure, and you can use the bay size and length, and it will be created. Otherwise, you can create your own element by defining different number of by creating you can create and create solid elements will be used by using up to 8 nodes. And a beam element will consist of at least 2 nodes. Okay, means by joining 2 nodes, you can only you can create a beam element. Okay, and each time you have to create a new beam, you have to create a node first. Then only you can create a new beam that will be connecting the nodes. Okay, so what are the place is that the nodes will give me the coordinates. Okay, we can get from there. From beam, we will get the axis, coordinate axis, get the beam number, as well as after giving the material property, we will get the material specification and the size also. We will get the coordinate of the place, the number to it by default. So as discussed, when you will open the STAAD, you will be given with the option of different structures. So one is your truss structure, another is a plane structure. It could be space structure, it could be floor structure. Okay, from truss structure, you actually mean when there will be members who will be carrying only axial force only and bending. Okay, for the structure. If we have to create a plane structure where there will be only one plane, suppose global XY coordinate system, along that only you can provide your load. So you can use the plane structure. And in space structure, you have all the 3 dimensions open. You can create your structure in all the 3 like any of the direction you like. So mostly for our design analysis purpose, we use space frame, you can say. And in floor structure, the floors are considered, means only one plane XY plane or XZ plane will be considered, and the floors should um, Just
सर कुछ समझ में नहीं आ रहा है, ना आपका कुछ आवाज आ रहा है सर। आवाज के चलते भी समझ में नहीं आ रहा है।
okay, let's see if it is working now. For me, am I audible now? Is this visible?
Yes sir.
Okay. So a new file in STAAD pop window where you can see uh, tools that are available in the so under this you have many options like one of the major option that will found is your view, in which direction you are viewing, means whether it is along the x direction, global x direction you are viewing, or global y direction you are viewing. There are tools, transitional repeat, uh, can see control page is there. So in control page, you have the where the application the putting your for putting your properties, okay, for assigning material properties and for conditions. This page control is required. Typical in your model that you are creating is your called main window. In your main window, you can see your the graphical interface of the structure that you are dealing with. On your right side, you can see the data area, okay, where you will find various. If you are creating a new, if you are creating new nodes, then you will see the node coordinates there on your data area. Sorry, data area. If you are creating new beams, beam elements, then you will find the beam numbers that are present and the location there, if and so on. Okay, so various tools that are used as discussed are your view tools in your toolbar. You will find, okay, and there are also rotational tools that are available. Using this, you can rotate your structure. Okay, you can zoom pan the structure. Some option is there. You can return to the whole structure. You can even see the 3D rendered view. Okay, other tools, other required tools are like your different types of cursors. Okay, cursor to select different uh, if you want to select the node, select the cursor on you the select on beam element will be selected. So using this, you can this is useful for putting the loads on the structure. So suppose you want to put a load on the nodes. Okay, a concentrated load you want to put on the node. So for that, you will use the node cursor to assign the load. And beam cursor, you will use the beam cursor to select only the beams. Similarly, plate cursor, the same purpose, surface cursor. Next is your page control in view modes. So in page control, you will find the uh, modeling modes where there will be you can give the data analysis and then design. And in your post processing, you will find the different reactions that are coming, the shear force bending moments, the displacement and animation reports you will get. Okay, this is flow chart where the using which the analysis is done. You have to first generate the model, then provide the inputs, then after loading, do the analysis, run the analysis, and view the results, and design and verify. Okay, so there is model wizard. Okay, we are running out of time. You won't be able to just now Bondal and how to run. She will show you. Bondal,
Hello.
yes, you are audible. Carry on.
Hello. I think all of you are listening.
Yes, ma'am.
Okay. show you a drawing. And the process of the conflict. This is a simple subtrade. And at first, here the support is pin support. The point load is point load is 50. The DL is 50 and it and the second okay. Now I'll show you
मैम आवाज कुछ नहीं आ रहा है.
See, this is a beam that madam has shown. You see the support condition is there, pin support, and two loading cases are there. Point load, and another is a UDL, and you can see the distance from left. It is 2 meters. The point load, UDL is there up to 3 meters. Okay, and beam is 0.38 meter, means 380 mm, and width is 290 mm. Okay, and madam will show you how to give the material property, the section property, and do the analysis. Yes, Bonali, run the video. Play the video, Bonali. See, we have thought to show you the software but actually, while screen sharing, it is not possible to run the STAAD profile because it is a pirated version. So anyhow, it is not running due to your net issue. So that is why we are showing you a recorded video that we have recorded the session of doing your for beginning your STAAD Pro, how to open the file and create the file and create various models on it. Okay. Yes, Bodali, share the screen. Okay, all of you, please write your name and roll number on the chat box for today's attendance. Okay, all of you start writing your name and roll number, and you write only once. Don't repeat.
सर जो पहले दे दिया है.
नहीं, दोबारा मत दो. पहले जो दे दिया है वो मत दो. Those who have not given their attendance, they only write.
Hello. Hello.
Yes, play the video, Banali.
Okay.
मेरे को दो डिवाइस एक साथ on है. When is your next class, everybody? At 12. So you please bear with us. You see the video, you will get some idea. So
Okay.
this is the yes, explain.
For this drawing, at first we have to go new project, and after that space and the file name and location, and the next, and after that add beam and finish. And from this tab we will see the drawing from x side, y, z, and this is the isometric view, this type. And after that, from this part, edit, and we have to send the Z. We will see the x and the x and y axis. Okay. And we have to click insert. Net connection is very poor. Please wait.
सुनाई नहीं दे रहा सर।
Yes, madam is actually starting another video. Are there? Okay, she's trying to running the another video. Actually, she's trying to show the steps that you have to follow while operating the STAAD Pro. So initially, what you do, you press the icon and you
सर कुछ
start
समझ में ही
the.
नहीं आ रहा है, नेटवर्क इशू का कारण ठीक से आवाज नहीं आ रहा, कुछ नहीं आ रहा है।
नेटवर्क इशू के लिए because of lockdown actually we are not having the net from your institute, so that's why we are doing it on our home. And actually everybody is doing school students also, so that's why there is a huge requirement of that data, and that is the reason why there is so much scanty of quality network.
सर अब टाइम हो गया, फिर अगले क्लास में बताइएगा। अभी अच्छा सुनाई भी नहीं दे रहा है, ना ही प्ले भी हो रहा है।
Okay, all of you write your name and roll number for today's attendance. This is so what to conclude today and finish it. So today we discussed STAAD Pro, the structure analysis software. I discussed the basics of analysis, how using finite element method the analysis is done, what is the basics, how the elements are created, the different using this creating the elements and joining them. We prepare the model and we give the assign the geometry description, and finally we give the load, and after that we run it, we find the analysis, and we get our output in terms of shear force, bending moment, for axial force diagram also we get. And designing for RC, we can perform the design and we can get the amount quantity of steel, and if we have to design the steel structure we can also do it. Okay, various design criteria could be considered for wind analysis could be done, and snow load could be considered, earthquake load could also be considered using this STAAD Pro. Okay, so that's all for today. You have next class also. I will. So let's hope that remaining classes have a good net connection. Otherwise, it will be quite horrible to.
थैंक यू सर।
वेरी हॉरिबल सर, भूत से भी ज्यादा।
Okay.
थैंक यू सर।
Thank you.